Have you ever gazed at the stunning geysers of Yellowstone and wondered what truly lies beneath? Beyond the breathtaking landscapes and iconic wildlife, Yellowstone National Park is home to one of the planet's largest and most active volcanic systems. For decades, scientists have been piecing together the puzzle of this massive supervolcano, and now, new research is revealing its secrets in unprecedented detail. What they've found is both reassuring and utterly fascinating. So, what's really bubbling under America's first national park? Let's dive deep into the heart of the Yellowstone Supervolcano. For a long time, our picture of Yellowstone's plumbing system was, to put it simply, a bit blurry. We knew there was a massive heat source down there, the Yellowstone hotspot, feeding the whole system. We also knew there was a large magma reservoir, but its exact size, shape, and state were subjects of intense scientific debate. Previous studies gave us a general idea, but lacked the high-resolution detail needed to truly understand the beast below. Imagine trying to understand the layout of a complex building by just looking at its shadow. That's essentially what scientists were doing. But technology has a way of catching up, and recently, researchers from the United States Geological Survey, or USGS, brought in the big guns. They deployed a combination of cutting-edge techniques to create the most detailed map ever of Yellowstone's subterranean world. The first technique is something called seismic tomography. It works a lot like a medical CT scan, but for the Earth. When earthquakes happen, they send seismic waves rippling through the planet's crust. By placing a dense network of seismometers all around the park, scientists can measure how these waves travel. Just as X-rays travel differently through bone and tissue, seismic waves change speed depending on the material they pass through. They slow down significantly when they hit hot, partially molten rock. By analyzing the travel times of thousands of these waves from hundreds of different earthquakes, researchers can build a three-dimensional image of what's below. It's an incredibly clever way to see the unseeable, using the Earth's own vibrations to paint a picture of its interior. But they didn't stop there. They combined this seismic data with another powerful method called magnetotellurics. This sounds complicated, but the principle is brilliant. The Earth has a natural magnetic field, and it's constantly being influenced by solar winds and lightning strikes, creating natural electric currents that flow through the ground. The magnetotelluric method measures how these currents travel. Just like with seismic waves, these electric currents behave differently depending on the material they encounter. Molten rock, or magma, is much better at conducting electricity than solid, cold rock. So, by measuring these electrical properties from the surface, scientists can map out areas of melt deep within the crust. When you combine the CT scan from seismic tomography with the electrical conductivity map from magnetotellurics, you get a cross-validated high-fidelity image of the magma system. It's like switching from a blurry black and white photo to a full-color high-definition 3D model. So what did this advanced imaging reveal? The results, published in the journal Science, were groundbreaking. Instead of one single, giant blob of magma, the team identified 4 distinct magma reservoirs stacked and interconnected beneath the park. Think of it less as a huge, singular, underground lake of lava, and more like a complex network of chambers and pathways. This completely changes our understanding of how the system works. These 4 bodies of magma are located in the upper crust, sitting at depths between about 5 and 17 kilometers, or 3 to 10 miles, below the surface. They are all clustered within the Yellowstone caldera, the massive crater-like depression left behind by the last super-eruption, 631,000 years ago. This discovery of multiple separate reservoirs suggests a more intricate and dynamic plumbing system than we ever imagined. Now, when you hear the words magma reservoir, you might picture a giant cavern filled with sloshing, molten rock, ready to erupt at any moment. But the reality is quite different, and frankly, much less alarming. The researchers described these reservoirs not as liquid-filled tanks, but as a crystal mush. Imagine a giant snow cone, but instead of ice and syrup, it's a mixture of solid crystals, molten rock, and volcanic gases like water and carbon dioxide. The new data allowed scientists to estimate the proportion of liquid melt within this mush. And here's the key finding. The concentration of liquid magma is currently quite low. In most of the reservoirs, the melt percentage is estimated to be between 5 and 15%. To trigger a super-eruption, scientists believe you need a much higher concentration, somewhere in the ballpark of 35 to 50% liquid melt. At that point, the magma becomes mobile enough to actually erupt. So, the current state of Yellowstone's magma chambers is more like a semi-frozen slushy than a boiling pot of soup. This means that the system, in its present state, is simply not capable of producing a super-eruption. The fuel tank isn't full enough. This is incredibly reassuring news and underscores what volcanologists have been saying for years. While Yellowstone is an active volcano that we must monitor, it's not on the brink of a cataclysmic eruption. But the study didn't just tell us about the present. It also gave us tantalizing clues about the future. Of the 4 identified magma bodies, one stood out. the one located in the northeastern part of the caldera. This particular reservoir showed the highest concentration of melt, and the seismic data suggested it was the most active part of the system. The research team concluded that if an eruption were to happen, and we're talking on geological timescales of thousands to tens of thousands of years from now, this northeastern magma body is the most likely place where it would begin. This is a hugely important discovery for future monitoring efforts. Knowing where the next eruption is most likely to originate allows scientists to focus their resources, like GPS stations, gas sensors, and seismometers on that specific area. It's like knowing which part of a building is most structurally vulnerable, allowing you to reinforce it and monitor it more closely. It helps refine hazard models and makes our monitoring of Yellowstone even more effective. This doesn't mean an eruption is imminent. Far from it. It simply means we now have a better idea of where to look for the earliest signs of any changes, should they begin to occur in the very, very distant future. So, what does this all mean in the grand scheme of things? Yellowstone is just one of about 20 known supervolcanoes on Earth. Others include Long Valley in California, Taupo in New Zealand, and the Phlegraean Fields in Italy. While super-eruptions are incredibly rare events, happening on average once every 100,000 years or so, their potential impact is global. An eruption on that scale could eject enough ash and gas into the atmosphere to alter the global climate for years, disrupting agriculture and affecting life all over the planet. That's why understanding and monitoring these slumbering giants is a global scientific priority. The pioneering techniques used at Yellowstone are now being applied to other volcanic systems around the world. Each new piece of data, each new discovery, helps us build a more complete picture of how these massive systems work. This knowledge is our best defense. It helps us differentiate between normal volcanic unrest and the precursors to a major eruption, allowing us to provide more accurate warnings and better prepare for any potential hazard. The new view into Yellowstone's depths is a testament to scientific ingenuity. It replaces old simplified models with a complex, nuanced reality of a crystal-rich mush, not a liquid-hot disaster waiting to happen. It reassures us about the present while sharpening our focus for the future. The story of Yellowstone is a powerful reminder that our planet is a dynamic, living entity. The ground beneath our feet is far from static. By continuing to listen to its rumbles and probe its depths with ever more sophisticated tools, we can better understand our world and our place within it. The sleeping giant of Yellowstone may still hold many secrets, but thanks to this incredible research, we're beginning to understand its dreams. Thanks for joining us on this deep dive beneath Yellowstone. If you found this journey into the Earth's interior as fascinating as I did, don't forget to hit that like button and subscribe for more adventures into the world of science. Let us know in the comments what other geological wonders you'd like us to explore next. See you in the next video.